S. Chan presents educational video lectures. Difficult concepts made easy. Study anywhere, anytime.
Hello students, and in the previous video we have done the probability calculation. So we can understand that how important is to calculate the variables which are linked with any kind of calculations.
If you want to study this topic in detail, refer to the book by S. Chan Publishing. Link is provided in the description box.
Welcome to the SN Academy. My name is Kanhaiya Jha. So today in this video we will discuss the dependent and independent variables, and along with that we will also calculate all the operators which are required to do this. Basically the different rules, and before this we will also discuss that the independence and the dependence variable here. So we start with here that defining the independence, that what is the independence. So independence in terms of the conditional probability is if we have two section P A and B, so P A or P B by A is equal to P B. So this, otherwise they are particular dependent. So this is the state where P A B is equal to P A or P B by B is equal to P B. So we can see that the two particular events, they are not dependent to each other, they are independent from each other when we have this particular calculation, which is P A by B is equal to P A or P B by A is equal to P B. So this is basically a state where we can see that it is a independent particular variable in the stats. It is basically, if you can see here, that if we have decided whether or not two events are independent, we can use the rule to calculate their intersection. So this is the multiplicative rule for the intersection. This multiplicative rule is for any particular two events A and B, the probability that both A and B will occur. That if suppose that we have to, from the male and female, we have to choose either male or female, and then there is a probability that it both can occur, then we have that for any two events A and B, the probability that both A and B will occur is probability of A intersection B is equal to PA, PB is given that A occurred. So PA, PB by A. If the event A and the B are independent, then the probability that both A and B occur will be this. So in the given event, in a given particular function, if there is a probability that one will occur and one will not occur, or both will occur or both will not occur. So when there is a case that both will occur, both the particular values can occur or both the particular values cannot occur, then we can use this particular independent value. Let us take an example to understand better, that in a certain population 10% of the people can be classified as being high risk for the heart attack. 3 people are randomly selected from this population. So what is the probability that exactly one of the 3 are on the high risk? So that in a population 10% are on the high risk that they can undergo with they can suffer from the heart attack. They are in a top high risk particular category. So if we have to select randomly, then what is the possibility that we can choose one of the person who are from this particular high risk category, that they are from this particular high risk category. So exactly one high risk category is that H for the high risk category and then normal and then normal. So we can see that if we select the one, we use the probability for the one particular function, then probability of the high risk and then normal, then it can be normal, then high risk, then normal, then it can be normal and then the high risk, okay, then it can be on the high risk, normal and then normal. So we can see that this is what the probability is. So accordingly, if it is the high risk, normal and normal is 0.9 and high risk is on 0.1, because we are selecting that 10% is from the 10% of the population. So this is how we make the calculation. So this particular independent value is that when both the values can happen, like that we are selecting two particular event and both the events can happen together, or none of the event will happen, or we can we can say that some event will happen and some event will not happen. Let's take more example for this, that we have the suppose we have an additional information, the previous, that we know that 49% of the population are female, also of the female 8% are on the high risk, that we have taken the previous example that 10% of the population are on the high risk factor of the heart attack. So from there only we can see that we know that only 49% of the population are female, and also of the female patient 8% on the high risk, that on the female patient the 8% are on the high risk. The single person is selected at random. What is the probability that a high risk female? So we can say that from this PF is equal to 0.49 and then high risk female is 0.8. So we can use the multiplicative rule, as we have discussed the multiplicative rule in the previous video. Then P high risk female is equal to PH intersection F. We can make the particular calculation. So see, from the total population we have calculated what was the high risk particular category, that how we calculate the high risk the particular heart attack. From the entire population we make changes, that what will be the female population, and from that female population how to evaluate the high risk factor from that particular female population. Okay, and after that from the female population also we can calculate the high risk factor, and from the total population also we can make a calculate a high risk factor, and then from the total population also we can calculate this. Sample space for throwing 3 dice has 200 entries, and sample space for throwing 4 dice has 1296 entries. At some point we have to stop listing and start thinking we need some counting rules here. So why 3 dice has 216 entries and then 4 dice has 1296 entries? So what is the criteria behind that, why this, how this calculations is generally done? So the rule is called as M into N rule. M into N rule, the experiment is performed in 2 stages. First M, with M ways to the first stage and N ways to commence the second stage. Then we have M into N. So we can see that we will divide the experiment into 2 particular parts. One is M, the M is the first stage, and another one is the N. So N is the second stage. So the total calculations can be done into M into N, that what was the M stage and what was the N stage. So making the 3 particular calculation M into N stage, we can make the total calculation M into N. So this rule is basically for the K stages with the number of the ways equal to, so N1, N2, N3 till N particular way. Similarly M1, M2, M3 till Mn till the nth particular way. So we can see that we are using M into N. So M is for the particular one stage and N is for another stage. So anytime we can use for M into N stage, and then we can make the particular calculation. So toss 2 coins, the 2 coin number simple event is 2 into 2. If you are tossing 3 coins, either head into tail, M into N, 2 into 2 into 2. So 3 times. When you are tossing, we make a number of toss. Number of toss will generally define, because each toss is basically has 2 things, either head or tail. So we have to calculate like this. Then we have example, we need to understand this example very carefully. Toss 3 times. So first time we toss it 2 times. So it was 2 into 2, 4. Now it is tossed for 3 times. So when we toss it for the 3 times, then it will be 2 into 2 into 2. So we can see that in the 3 times it is 8. Okay, suppose the total number of simple event is 6, so it will be 6 into 6. Total number of simple event is 6 into 6 into 6. Again we write, because when we throw a dice, there are 6 chances. Either we get 1, 2, 3, 4, 5 or 6. So one we throw it once, the 1 into 6, 2 into 6, 3, then we 6 into 6, every time 6 into 6, then again 6, again 6, depending upon the number of throws. So again M&Ms are drawn from the dish containing 2 red and 2 blue candies. The total will be 4 into 3. So what we learned here is that we are breaking the experiment in two particular stages. One is stage M and another one stage N, and the total calculation will be done with the stage M into N. So here what we conclude is that we conclude the variables which can be declared as an independent variable in the probability, how we make the calculation with the independent variable with a particular probability, then how we are using the M into N formula, that what is the M into N and how we are going to make the calculation with the M into N. We will break the experiment into two particular parts, one is the M and then another is the N, and then in the calculation we will use M into N. So we will take a small break now. After this we will again study further with the independent variables.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
So we were doing the independent variables with the probability. We were doing the M into N factor. We have done that how M and N are generally used. Just making a small revision that we have taken few examples where we have taken that we throw a dice 2 times. Okay, the total we throw a coin 2 times, so 2 into 2 into 2, 3 times 2 into 2 into 2, because each time the M into N will be M into N, so either head or tail. Then we throw a dice, so each time the dice has a probability of 6. So if you throw it once, it will be 6, 1 into 6, 2 times 6 into 6, 3 times 6 into 6 into 6. So number of times that we throw a dice, it will be multiplied by 6. Then example, 2 MMs are drawn from the dish containing 2 red and 2 blue candies. So we can make a number of events like 4 into 3, 12 candies. We will proceed further now that we calculate the permutation of this. Okay, so the permutation is that log consists of 5 parts and can be assembled in any order. The quality control engineer wants to test each order for the efficiency of the assembly. So how many orders are possible? So how many orders? This is called as a permutation, that how many orders are possible. So it can be done in 5 parts. So when it can be done in 5 parts, we will use the probability 5 to 5, the 5 factorial. 5 factorial, when we solve it, then it will be 5 into 4 into 3 into 2 into 1. So it will give the result 120. So we have to calculate the factorials in this. Okay, this is in terms of the permutation, that the exact possible way that we calculate in permutation. Here we can see that it has given that it has 5 parts. Okay, and the quality engineer want to test for each particular order. So how many ways you can test? So 5 factorial is there. So we will calculate the factorial 5, and the factorial 5 is 5 into 4 into 3 into 2 into 1, that will be equal to 120. This will be the 5 factorial. Another example of combination that we take, a box contain 4 red, 2 green. Okay, a child has to select 2 M's at a random. What is the probability? Exactly 1 is red. So here we will use again the probability permutation, that the child has to select the particular value. So total number of box 6, 5, and the child has to select randomly that what is the probability that exactly 1 is red. So if 1 is red, 2 5 into 4 5. So because then it will be 6 into 5, 2 into 1, that is equal to 15. So we have to choose 2 M's. We can use the so C1 to 2, where you can use this particular value, and then C1 to 4, where we will get this particular value. So permutation is basically that when we calculate the total value and from the total value, given number of values has to be calculated. Like in the earlier example, previous example, we have taken that a lock consists of 5 parts and can be assembled in order. The quality engineer wants to test it. Each order is efficient of efficiency of the assembly. So when you want to check the assembly of each particular part, so we can say that it has 5 parts, 5 factorial. So 5 factorial in the sense that 5 into 4 into 3 into 2 into 1, that is equal to 120. So these are the examples we have discussed for the permutation and some example of the combination also. Let's take one more example here. The deck of cards consists of 52 cards. So there are total number of cards which are 52, 13 kinds of each 4 suits, spades, hearts, diamonds and the clubs. The 13s are, is we can see A, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack is denoted with G, Q is Q and the K is the king. Now in how many poker games each player is dealt 5 cards from as well as shuffled deck. So we will see that how many cards are required, 5, and what are the total number of cards, 52. So as we have discussed, the total number over the required number, we have to calculate. So we will calculate 52 factorials over 5 factorials, 52 minus 5, because 52 factorials are total and then the required number of 5 factorials. So we will calculate a 52 minus 5 factorials. So we can see 52 into 51 into 50, 49, 48, and then 5 factorials will be 5, 4, 3, 2, 1. So this result will be the result where we will get the 5 cards in a row. So we can see that the total number of cards are 52, and from that particular 52 cards we want 5 particular cards. So we have that combination says that 52 the total number, and from total number what we need is 5. So we have 52 factorial over 5 factorial. So we will calculate both the things and we will calculate it. Similarly, if the question says that there are 100 cards and out of 100 cards we need 10 cards. So we can say it's 100 factorial and then it is 10 factorial. So the total number of events over the required events. Then we have another example. There are 12 kind remaining which is selected to each 3 cards in the hand. We must insist that the kind be different from each other and from the kind of which we have a pair, or we could end up with the second pair, 3 or 4 or given kind of pair. So we can make the pair also along with this. Look here, there are total 12 cards and we are looking for the 3 cards. The total is 220 ways. So we can make this calculation also. This calculation will basically used as 4 cube is equal to 64. Again we are breaking 13 into 6 into 220 into 64 and the probability will become this. So we can say that in this permutation and the combination, that what we have to do is that the total number of events are given to us, and from that total number of events we have to select a given particular event. So in always what we will do is we will select the given number of events in each case. So key concept here is that sample experiment events mutually, the sample space, the probability, relative frequency, definition of a probability, property of the probability we have already discussed, the sum of the probability for all simple cases. Containing rules, m into n rules, we have done m into n rules. Permutation is saying that p r to n is n factorial, n minus r factorial. N factorial is the total number of events and the n minus r factorial is the required factorial. Similarly, for the combination we are using C r to n, r, then r factorial, n minus r factorial. Then event relation is the disjoint and then complementary PA is equal to 1, so it will be 1 minus P A to the combination. So we have discussed this P A by B is P A intersection B over P B, and additive rule is P A intersection A union B equal to P A plus P B minus P A intersection B, and the multiplicative rule is P A intersection B is P A P B by A. So here we can see that we have done the m into n rules, we have done the permutation rule, we have done the combination rule, we have discussed that what are independent variables, and we have discussed that from all the particular probability how to calculate the given probability. that the particular probability is given, how to make the calculations. So we conclude here the chapter probability where we have done the operators, the calculation of the particular operators, and how to make calculation with the permutation and combination with the probability. Hope you have enjoyed the video. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.